Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and good afternoon for everybody. All right, so thanks again for PJIM. We call here is PJIM, Pejabat Jaringan Industri and Masyarakat, for this event, for this knowledge transfer KTP programs, which is it's a good to us have sharings, and then to let the industry especially to know what we have and what we can uh, provide. I mean, especially in terms of industry scopes, right? So, right. So first of all, I would like to um, just a quick introduction to the UTEM, especially, right? So everybody know. So it's situated in UNESCO heritage sites, historical city of Malacca. And then this weekend we have another history for Malacca for the PRN, right? Talking about UTEM, basically, if you look at here is um, so we are a university basically is focused on the technology basically for the advanced industry. That's our target. That's our focus. Basically, in Malaysia we have the network university we call MTUN, which is this university basically we focus on this technology. That's fact. If you look at in our university we have several degree, right? So we have engineering, a degree of engineering, degree of technology engineering, engineering technology, and then degree of a bachelor of technologies. So this is quite a different program basically. So right, so let's just a quick for introduction from my faculty. So we offered a program from a diploma until for PhD, and then I just want to highlight one of the special, especially special for industry, right? For doctorate in engineering, DEng, right? So we have graduated few students, right, for from this doctorate engineering. Is a bit different from the doctor philosophy, because this doctorate engineering basically we want to focus on to solve the industry problem, right? So that's the aim of doctorate engineering. Okay, so then of course when we're talking to solve the industry problem, we put on confidential, I mean, in terms of the safety security of your data, right? So it's a bit different in terms of requirement as well. Okay, so this is a chance for basically for industry, right? So if you want to join us, right, so to solve your industry problem, and then after that you got your PhD, right? So this is your chance. Okay. So others, we have another postgraduate talk course as well. In basically, we have a Master of Electronics Engineering in Telecommunication, Computer Engineering, and Electronic System. In for the undergraduate program, we have two. I mean, quite strong in industry, basically in electronic industry, and then this is new one. This is computer engineering industry, which is very related to the. In fact, we designed this program is I mean especially for IR 4.0. So that's a bit different if I compare to this another program is in around here in Malaysia especially, right? So it's quite news, and then it's quite challenges because it is exactly. I mean, we compare and we mapped most of these syllabus or curriculum from the United States, and then from the surrounding Europe and China as well, right? So it's a very good program basically. All right, so today um, a bit introduction to the try to share. All right, so bring you all to what is computer vision, and then what is and how is it related to the IR 4.0, and then let's look at the resolution, right? So in this computer vision, and then a bit talking about some of the um, potential collaboration, potential, working together in between university and in industry, right? We start with, of course, when we talking about the new things, we're talking about the definition first, right? So let's look at some of these are just a take from this reference from Wikipedia, and then some of the another one is from the SAS. One of the good reference for computer vision. If you read a bit different in terms of this computer vision definition, right? So look at the first one. Wikipedia is computer vision is interdisciplinary scientific field that's deal with how computer can gain high level understanding from digital image or video, right? So this is from Wikipedia. And if you look at another one, is a computer vision is a field of artificial intelligence. Okay, this definition talking about AI, right? And that train computers to interpret and understand the visual world. So that using digital images from cameras, video, and a deep learning model, a machine can accurately identify and classify the object, right? So this is a definition. So this is definition basically is related to the AI. So where this computer vision in AI, we'll be talking later on. And then let's look at this. Sorry, from the image, is comparison basically in human vision system and a computer vision system. Right. If you look at the input, it's the same input, right? The image, right? So you can see the fruit image here, and then in middle, so you can see for this human, of course, you have your brains, and then the sensor here. I call sensor is eyes, your eyes, and then in the computer system, of course, the sensor is camera itself, right? The sensor camera, sensing camera, and then computer is a device to interpret, right? So and then the same output, right? So for human is automatically, I can say, it's automatically you're able to recognize, right? You're able to recognize the colors, the object itself, right? So but the computer vision, you need to train, you need to teach, right, to this system, right, to teach this object what's kind of object, right? So what's kind of the uh, specification of the image and so on, right? So that's between, the comparison between human vision and in computer vision. And if you look at the computer basic vision, basically the aim is to replicate, right? So what's the human vision availability, and then try to translate into the computer vision, right? But it's not so simple, right? Basically, to translate in this human ability and then to the computer vision system. Another one's the advantage of the computer vision. Um, the ability of human is cannot be uh, do or cannot be done for this for use our eyes. For example, the small thing and the very tiny thing, right? So that's why we apply this computer vision, because with computer vision we are able to zoom until a very micron image and so on. So that's another the advantage of the computer vision in terms of comparing for the human ability. Okay. Right. So let's look at what is industrial revolution. I think something is very hot. I think especially before the pandemic COVID, every conference talking about IR 4.0 and so on. I think in Malaysia, I think it has been a hot topic since 2000. 2018, I think, right? So they're starting, or 2017, they're starting to talking about this IR revolution, right? So if you look at IR revolution is going automation of traditional manufacturing industry practice, which is using modern smart technology and the large scale machine to machine communication M2M, and then Internet of Things. All right, so if you look at the revolution, right? So from the first industrial revolution, second industrial revolution, third, and now as we go in the fourth industrial revolution, right? So what been highlighted is more on this ability, right, to do in automatically, right? So we are able to monitor and then do the action execute with something is automatically is automate, right? So that's another the idea of the IR 4.0, right? Um, so then, of course, AI is a play the main role, right? So in this IR 4.0, right? So this is a for like what I can call is a component of for the or characteristic for the IR 4.0. So the first one is sorry. Okay, for the first one is connectivity, right? So very important, the connectivity. So in fact, now when we facing pandemic COVID, so then we see how important this internet, how important we can get a very high speed internet, right? So there's therefore IR 4.0, the connectivity, right? So the power and data and so on is very important, right? So another thing is look at the IR 4.0, we're talking about the Internet of Things, right? So when we're talking about Internet of Things, so of course the main component is sensors, right? So then we must have a very robust sensor, right? So we have a smart sensor and so on. Now people now talking another advance from the Internet of Things we call uh, artificial Internet of Things, or AI Internet of Things, right? So that's another current, right? Current, it's not technology, it's a combination of this advanced, right? So if you look at most of the now Internet of Things is just you're able to control, you're able to monitor and so on, right? But now we want to we want to further advance in terms of technology, which is, the outcome of the device is able to do, right? So by itself to automate to do something else, right? So everything is controlled by AI. So that's the idea and in the future technology, right? Because in the research here now we start to talk about that, right? We thinking about that in another 5 years, right? For this Internet of Things. Another technology where you now demand is a cloud technology itself, right? So we have a data science, right? So that's another, uh, hot industry. In fact, in UTM, there are many requests and demand okay, for the training or the short course and so on for this data science. Right? In fact, if I look at the participant, it's not background of IT as well. Sometimes it's from the financial, right? So from engineering or from another field which is not have a background of computer science, but that because of the demand of data science, so people is eager to get this knowledge. Okay. Okay, second one is analytic intelligence, right? So the analytic intelligence, of course, analytic mean talking about the data itself, right? So we want to analyze, we want to train, we want uh, to teach the system which is able to do very smart thing, right? So this is analytic intelligence. The third one is human mission integration. Right, this is another. It look like a robot, right? But this is very smart robot. Right, so the idea is a very smart robot. The robot can do itself without any controlling from the human. Right, so that's the idea for the IR revolution. And then of course the technology now moving to that. Okay. Okay, the last one in number 4 is advanced engineering. Right, we're talking the renewable energy, right? Of course, it's very important, right? So you have a system with renewable energy, right? Smart energy and so on. Okay, and then talking about the something 3D printing and then nanoparticle, and it's many things on the advanced manufacturing. Okay, right, right. So I think we should discuss a bit about the history, right? So if you look at history of computer vision in this aspect, look at it since 1957, right? So it's in Merdeka Day lah, right? So they in United Kingdom, and they start to have a first computer scanner, right? So in 1957, this is technology of computer vision, and then followed by defense uh, contractor, right? For right, so this uh, for the facial recognition system. So they started on the 1964, and then in 1976, so the UK police the invent this license plate recognition system. Okay, and then look at this 85 is first autonomous land vehicle in 1985. And then look at the 2004, they sent this Mars rovers, right? And then in 2008, 3D printing, and then 3D, everything on 3D. Okay, and 2010, Microsoft Kinect, right? So this is start for interaction. Okay, and then of course since 2014, everybody have your own smart camera and so on, and then embed so many intelligent things inside it, right? So there's a moving forward now until 2021. Of course, so many things now, right? So I'm so many smart things inside or in your hand, especially, right? If you got your smartphone, so many capability your smartphone. Okay. All right. So this another one is you look at here is a comparison between um, the growing of the image device, which is we refer to the hardware, and then the computer vision concepts, right? So if you look at optical character reader, is basically start from 1914. It's a long ago, right? Don't look at until now, until vision robot and so on. So this is talking about the hardware development. This is talking about the concept. I mean, the on the software part basically, right? So the start of automatic stereo until now is everybody talking about deep learning, yeah, deep neural network, and so on. All right, so let's look at what's the impactful of this computer vision technology. All right. Um, hand, handwriting recognition. So how important this is handwriting recognition, right? If you remember, I think 20 years ago, we still depend on when you send a letter, right? You send to post office, you know, and then you write the address with your handwriting. Okay, that's starting on this technology of computer vision, which is they develop a technology um, to separate, right? To separate, to recognize your handwriting, and then in the system to separate based on the postcode, right? So they're helpful basically on that time. I think in the 19, in 19, in I think late or 1995, I think, right? So they're starting on this. I mean, on this. handwriting recognition apply in post office, right? But nowadays, um, the growing the application and now to the tabs, right? So you're able to jot note on, you're able to write, and then it's automatically convert. So let's look at it for this example, right? You write, your writing, your handwriting, and then it's automatically convert, and then you automatically can send your email or any for documentation, right? So that's look at it, how impact this technology. Okay, face recognition, right? So this is another important today, all right, for basically for the biometric, right? For the biometric, in fact, in a certain country they use for the tracking, tracking the people in case you have a crime case, for example, right? So they refer to the CCTV and then track the person or any target, right? So using this face recognition, right? So this is uh, I mean growing technology itself, right? Especially if you want to enter, this is biometric, you see that. If you want to access a door, access a building, so instead of using the fingerprints, so you can use your face as well, right? So this is technology for this face recognition. Another, I mean, is in fact until now is a very hot topic for research. Is for the health care, right? So we want to develop so many automate detection system, right? So look at the example, right? So this is to detect the region, abnormal region, basically, right? So, and then this is again, yeah, from here, right? So from the image, raw image, we try to have a system that able to detect something abnormal, basically. Similar here, right? So this is to detect from right. Okay, so and from the X-ray, from the chest X-ray, right? So we are able to classify type of disease, right? So for the MIA and so on, right? So maybe nowadays people start to try to recognize COVID, right? COVID-19, of course, right? So that's analogy. There's many apply, and then now they're talking hot many on the on detection of cancer, right? From the image, right? Okay, sorry. Um, this is a multidisciplinary. If you look at in terms of multidisciplinary, we have apply in many disciplinary for the engineering, of course, computer science, of course. But if you get another cross disciplinary is a psychology, mathematical, of course, because when you apply um, deep learning or AI, so many mathematical things, right? Biology, physics, and so on. Let's look at the current and the future expectation or application for this computer vision. So it divide into 8 category here, right? So healthcare, as I mentioned, for the care of cancer detection, right? So the movement analysis, right? For the post analysis, basically for those injured, right? So we want to analyze how growing your recover, right? So this is another way, right? So this is still using this computer vision technology, tumor detection, right? So this is a very hot topic now. Okay, people on the research area work many research in this healthcare, right? Right. Another thing is banking. So talking the banking, where we apply this computer vision, right? So banking, for example, for detect the fake check, right? So we apply this technology, computer vision, and then for this suspicious behavior, right? Sometimes people enter bank, right? So So one of these smart of the competition, we are able to read the behavior of human or people, right? So this is another way where the banking can apply, right, for this competition to identify the suspicious behavior. Okay, automotive, of course, right? So now talking about the autonomous car, right? So self-driving car, everything on this automate, right? So again, right? So computer vision is a play the main role here, right? So to as a sensor basically, right? To sense all the surrounding, right? So and then do the decision making for the car. So this is current and the future as well, right? And plate number detection something as old, I mean, has been established. I mean, 20 years ago, right, to plate number detection and so on, right? So, but in Malaysia, the issue is we don't have a standard plate number, right? That's another challenges basically for to develop this system. We don't have a standard compared to another in the I mean the example from United Kingdom, Europe. So they have a very standard numbers in terms of size. I mean numbers are every single character is they have the standard, so easily to system to detect, right? So Malaysia they very fancy. You have so many fancy numbers of a plate, so it's very challenges from the spot, right? From the spot. So basically, you can see now, if you mean a fan of football, right? You can see now is a referees depend on VAR, right? So this is another technology that's really apply on this sport, right? So again, but still have a room of improvement, right? So because again, of course, when I see did not do automate detection, because sometimes referee have to refer, right, to have to go uh, okay, go to the a camera to to double check, right? So that I mean the player is offside or the goal is has been uh, goal or not, right? So again, there still have a um, things are to improve, right? So suppose they can able to detect automatically in real time, right? So no need to you delay the game and so on, right? Okay, I believe in another 3 or 4 years that they have kind of this system which is able to detect immediately or real times. All right, another industry basically, right? So that apply this uh, computation is a manufacturing industry, of course, right? For detect the defects of product, right? So of course, and then barcode reader, of course, for to track the product and then the employee movement and so on. Okay, surveillance system again, this is very important, right? For hopefully uh, the government I hope can look at this important of surveillance, right? So because in another country they invest more on this surveillance, right, for the safety and security, but quite less in Malaysia, right? So hopefully they need to look at seriously on this surveillance. Right. So then agriculture, of course, right? So you know, for example, for the farming activity monitoring, so and then quality detection, soil crop condition, and so on. Insurance, right? So insurance is another industry basically. They can apply this computer vision. So, for example, so minimize instead of fraud, which is assess picture of the accident. So this computer vision we were able to check basically is that your image that you send is real image or something has been copy and paste, something has been edited or not, right? So there's another things on this technology, right, to help basically in this case for the insurance industry. All right, let's talking about where is AI basically in computer vision. All right, so this is look at the computer vision, and then look at how it's crossover on the machine learning and artificial intelligence, sensoring, so biometric, robotic, and so on. All right, so these are another things. So look at AI. When we're talking about AI, so we're talking about the machine learning and then deep learning. All right, so where is AI? Where's the machine learning? Where's the deep learning? Okay, this is I mean, look at the evolution of this AI, starting from 1915. We start from some very uh, automate decision, and then start from 1918. We start with introduce for machine learning, right? Machine learning, okay, and start from 2010s. So deep learning come out. Right, so basically this evolution basically is just improve for one per one. Right, for example, machine learning is improved before that. So deep learning is something introduced and then is to improve right, what the machine learning has been introduced. So this is basically a comparison. Many people ask what are the difference between machine learning and deep learning, right? So this is example, right? Input and output, the same input and the same outputs. The difference is so a middle, right? So a middle process. Okay, so the machine learning, you have another one of the process we call a feature extraction, and another process for the classification. But for deep learning, it's combined together. So the feature extraction and classification combined together. All right. So that's in fundamental the difference between machine learning and deep learning. This example, right? For example, to image, right? To so inside um, for the machine learning, you have a features extraction, and then there is a I mean, for the classifier to decide to right this from the input human design for the features selection, extraction, and to until the decision maker, right? So this deep learning is combined together, right? So from the feature extraction and so on until they produce the same output. So talking about the output, talking about the performance, of course, so deep learning has kind of produce a better outcome. But of course, deep learning is talking about the costly, right? So the computational cost is very high, right, compared to this traditional, I mean, machine learning, right? So that's sometimes depend on the application because if the application is simple, right? So it's better you apply the traditional one, right, compared to the to adapt to or use this deep learning. So that's again is depend on this application. This is a list of techniques, right, that's apply for deep learnings. This example: classic neural network, convolution neural network, right? So recurrent, RNN, CNN, and so on. So many things, you know. All right, so again, from single image, right? So you computer be able to retrieve, right, to extract many information, right? So the example of two boys, so the computer vision able to retrieve all this information. I mean, for example, um, what the color, right? The color of shirt, you know, the color of shoes, and then look at the behind the boys, and then what kind of, I mean, things or object that the both of boys is hold. Right, so many. Right, so look at this is from when we run this computer vision, we can access so many information from the single image. So what are the challenges? Of course, outdoor scenario, talking about the computer, camera. So the issue, of course, I mean, the outdoor condition, right? Especially the lighting. So the lighting condition, right? So and then in Malaysia, right, always raining. So there's another factor. The challenges of for the computer vision. Okay, right. Another one is of course on hardware, right? So hardware, how we want, because we try to have all this the smart thing in I mean embed in hardware. I mean in something um, portable, right? So that's challenges if you apply to embed in portable, because we need to consider on the processor things, right, on so on, because you run um, algorithm basically, right? So the algorithm is uh, take I mean process or uses the power consumption and so on. So that's the challenging when we embed this computer vision algorithm into the hardware. Okay, let's talking about academia and industry, right? So in Malaysia, what I'm see industry still I look at a university basically as more on this I mean teaching and learning, you know, and then um, and then somewhat of research, right? But basically now, wow, in I mean, not just in especially in UTM, right? So we more serious, right? So we more serious to collaborate with industry, okay? Not only for limits for the development of curriculum, but we look more on the uh, technology solution provider as well, right? So industry have problem, right? So engage with us because why? Because for us we very aggressive on the research, right? So we have all these current and then the future as well, for the technology, right? For the knowledge, right? For the information as well. So that's now the trend now is not only on academic, right? But we talking about technology solution provider as well. Okay, instead of community services, right? So as today is about knowledge transfer, right? So that's I mean we hope, right? If you look at the scenario in Europe, for example, right? When I was studying Europe, so we see how serious industry always get engaged in with university, always to keep in touch, right? Because normally university have always produce a new idea, right, and new things, right, and then so that hopefully in Malaysia they have some the same belief, right, from the industry. Germany, of course, right? Germany, of course, in fact, many university has been, I mean, park in industry. Okay, so that's hopefully this culture, yeah, is will be able in Malaysia as well. All right, so let's look at what we can provide basically, especially in computer vision. Right, so this is of course industry. We have so many camera sensor, right? So in different application. So this example application, right, to basically to inspect, right? So inspection and so on, right? So again, we have this knowledge, we have this expertise, capability to help the industry, right? So uh, I share some of my experience because industry approach. Some of them is engineer. They're able to use all this camera technology, but in terms of knowledge of fundamental, they lack on this. I mean this. I mean knowledge, right? So they you do not know what is basically the image characteristic, right? So the image processing fundamental, right? So they just only apply, right? So when they have found problems on, so it's a little bit hard to solve the problem, right? And then most of the problem um, referred by industry to me is talking about they try uh, to have a adaptive threshold. Right. Sometimes they said they just set the threshold based off their view, but basically we can have a threshold. Basically, like for example, in this case, right, to convert to this black and white from the color to black and white. So the technique is to use a threshold value, right, to convert that. But again, some of the results from threshold is different, right? Because when you set uh, the same threshold but a different image, of course, the output is different as well. Okay, this example, for example, like this example where the image is embedded so with a noise. So noise can be come from this hardware, from the camera, from the environment, and then from this when you send the image, right? So the noise can be embedded. Now we solve with apply the filtering, so they can much improve the image, right? So that's another simple I mean application which is we able to help the industry, right? So this example if for the region of interest, right, from the right, so from the X-ray, right? So we want to just focus on the region. So we apply very simple um, fundamental of image processing. Then to make the I mean the next process is much easier, right? This is another simple, right? So simple algorithm that we apply, right, for image processing, and that we can help basically to for example on this region, for example, and when we apply this all this algorithm, so you can see, right, so the blood vessel is more clear, right, compared to the input, right? So this is another example, right, for the simple image processing. The impact is very big basically for the industry. All right, so right, so I'm talking about technology solution provider, right? So this is one of the way, right, how we industry and any university can work together, right? So we are solution provider. So they can categorize into three scale: small scale, medium scale, large scale, right? So a large scale, of course, we're talking something big, a million, right? A million or thousand, right? So that we can apply from the grant, industry grant, for example, crash from the MOSI grant, right? So which is work together with industry, and then of course, large scale, of course, the duration is I mean, it takes time, 3 years, for example, 2 years, right? Sometimes until 5 years, right? So it depends on the project, of course, the big scale, right? So the large scale. The medium scale, for example, for PRM, the term maybe is 1 year, right? So, and then we have a university in UTEP, we have matching grant as well, right? So matching grant means half of that from industry and then half of that is from university. Okay, this is another, I mean, another chance, right, for the industry to work together. And not to forget, so we have a small scale as well. This is industry should know. So we able to work very small scale to solve your problem. I mean, immediately, right? So we put on the consultancy work or the contract research as well. Right. So basically, just this one for example, to contract research for 6 months, right? For 3 months, right? To solve your problem, and then for the consultancy work, also, of course. Right, so it's based on the how fast we can solve your problem, right? So all these things, of course, we need some documentation. It's very simple documentation, especially for the small scale, right? So this is the idea how we want to link, right? So in industry basically, right? To solve, right? To solve or to give a technology solution provider. And then the good news, especially for the industry. So now you tell me have, able to double tax deduction, mean industry able to double your deduction tax. Okay, so this is not all the university in Malaysia have this entitled to have this double taxation. So UTM is one of the university appointed or granted by ministry. So all this industry that work with us, they're able to do this double tax deduction. Okay. So this is some current I'm using. I'm a professional from this certified for the HRDF, right, for the register and so on. So now as we active and aggressive to industry basically, right? We have this kind of the computer vision pattern recognition competency course, right? So basically, of course, industry apply from this HDF. So industry use this HDF claimable, right? So there are two ways basically. It's in one project, right? So just so we now do one industry in Finian, right? So deliver this this competency course, right? So then it's all your time, right? So just let me basically we discuss, right? So what's your suitable time, your free time to deliver, either the normal day or the weekend, right? So we can do that for that, right? So this is the way was because we want to make sure all the the workers or that's apply using this computer vision in their work, they understanding, right, the concept basically, right, they hopefully they able to apply uh on during their work because based on our experience so many sometimes the workers have some issue, right? But that's not know to how to solve, right? So again, when after they go through this competition competition course, they helpful for them, right? To give an idea to more understanding what they're doing, right, from this competition aspect or their and their job aspect for in competition. Right, talking the on the future, right? So how this in the future you can expect, right? So from nowadays look at many all these sensor embed in smart transportation, right? So I mean, but of course that's in the in the vehicle yang mahal lah kan. So now I believe in another 5 years, all this technology is embedded in MIV and so on, right? In very affordable car, right? So right, so this will be will surrounding us in another 5 years, right? So that aspect now people start to research on the 6G. In fact, 5G is not arrived in Malaysia. People start now in 6G. Another in future technology, of course, architecture authorities are building industry. I think nowadays many of factory they have this smart drone, right? To have no need to have to climb again to check the roof of the building, right? So you just send this drone, right, to do them inspection and so on. Okay. Filmmaker, of course, right? So to drone is one of their I mean their vehicle, right, to make the film is more attractive. Okay, parcel delivery in Malaysia, I'm not sure, and because we have a heavy renting and so on, right? So a bit risk, right? So to have this kind of system parcel in Malaysia. Um, Right. So another thing is human-computer interaction, or called SSI. Now, of course, we during this pandemic, right? We experienced to sit and then facing a computer inside it's a longer times, right? Right. So, but in future, I believe, right? So, and then there is in fact, the display, the touch screen has been getting cheaper later on, right? So many application, right? So it's interact between a human and a computer. For example, now I have a system for the lie detection. Okay, so I developed the system lie detection, and then so in future, of course, there is a in psychology part as well, right? So in counseling, motivation, coaching as well. This is you able to interact on computer, right? Uh, so it look like a robot, right? So you just interact this your computer, right? And then so to talking about the basic counseling on coaching and motivation as well, I believe. Gaming as well, right? So this is this is future technology, right? That we expect that we will boost, right, in another 5 years. All right, I think that's all for my presentation. Okay, so more detail, you can take my contact number, right? So do not hesitate if you have any problem and nothing to discuss, right? Just call me, right? So give me a call or just WhatsApp me, right? So using this number or just email me, right? So hopefully we can further discussion, not limited to the computer vision. So I engage as well on this IoT as well, right? So AI IoT, right? So that's another uh, technology, right? So we look at very serious, and then again we try to engage with industry as well. Okay, that's all for my presentation.